Welcome to This Explainer. You know that feeling of anticipation, right? We're about to click that iconic green flag and start building an interactive digital world entirely from the ground up using the vast, colorful library of Scratch 3.0. Our goal today is to really demystify visual coding, transforming those brightly colored puzzle pieces into complex, logic-driven mechanics. Let's dive in.
Okay, here is our roadmap for today. We'll be covering 1. Movement, looks, and sound. 2. Events and taking control. 3. Sensing the digital environment. 4. Operators and advanced logic. 5. Variables and data storage. And finally, 6. Creating custom blocks.
Section 1. Movement, looks, and sound. Establishing a physical presence. Every great creation has to start with a physical presence, right? So we begin our journey by giving our sprite a body, a voice, and an exact location on the stage grid. Notice Scratch's absolutely brilliant color coding system here. Blue blocks always control motion, so dictating coordinates and direction. Purple controls looks, handling costumes, size scaling, and rendering layers. And pink dictates sound, managing audio playback, pitch filters, and volume. Seriously, this color system is going to be your best friend when navigating the interface.
Now there's a really important nuance within those blue motion blocks that trips a lot of people up. If you use set X to a number, your sprite instantly teleports along the horizontal Cartesian axis to that exact fixed coordinate. It's an absolute position update. But if you use change X by a number, you're adjusting the position incrementally. You're physically moving the sprite step by step from wherever it currently is. It's basically the difference between instantly warping across a room and just taking a few steps to your right. We actually see a very similar nuance with the purple looks blocks. When you want your sprite to communicate visually, you've got options. You can use say for a set amount of seconds, which automatically hides the message after the time expires, which is perfect for a cinematic effect or a timed back and forth conversation. Or you can use the simple say block, which leaves that message up indefinitely until it's specifically cleared by another block. It's a subtle choice for sure, but it radically changes the pacing of your animation.
Section 2. Events and taking control. Breathing life into your world.
Now that our sprite exists physically on the stage, we need to tell it exactly when to act and how to behave. So, step 1. The yellow when green flag clicked block acts as the starting gun for the entire project. Step 2. We snap an orange forever block directly underneath it, which creates a continuous loop. And step 3, we nestle a blue move 10 steps block right inside that loop. Just by dragging and snapping these 3 specific shapes together, we've instantly created a continuous background process that will move our sprite forward endlessly.
And this next block brilliantly illustrates how sprites actually communicate behind the scenes. A broadcast sends a signal message to all scripts in the project without waiting for them to finish. Think of it like an invisible radio signal. One sprite can hit a button, broadcast level 2, and instantly, asynchronously, every single other object in your game can react to that exact same signal. It is the absolute key to coordinating multi-scene transitions.
Section 3. Sensing the digital environment. Reacting to the world. Let's be honest for a second. A game isn't very fun if nothing reacts to you, right? So let's give our sprite some digital senses using the light blue sensing blocks. These triggers allow your sprite to detect physical collisions with other sprites, or even specific pixel colors on the stage. It can calculate the exact straight-line distance to your mouse pointer. And incredibly, it doesn't just sense the digital world, it senses the real world. By utilizing the loudness block, your game can actually react to the audio volume detected by your computer's physical microphone. Meaning, yes, you can literally code a game that requires you to yell at your screen to win. How fun is that?
You can also directly interact with the player using the light blue Ask and Wait block. When this block triggers, it completely freezes the script and prompts the user with a dialog text box directly on the stage. It literally pauses code execution until the user types something in and hits enter. That text string is then securely stored in the light blue answer block, which allows you to seamlessly process their input data and totally personalize the gameplay.
Section 4. Operators and advanced logic. The brain of the operation.
Let's move over to the green operator blocks and see how this builds the mathematical and logical brain of your creation. These bright green blocks come in hexagonal and rounded shapes, which are specifically designed to nestle perfectly inside the input fields of your other blocks. They perform everything from standard math and picking random numbers to comparing logic states to manipulating text, like joining 2 text strings together or even extracting a specific letter based on its numerical position index.
The really crucial point here is how we use those hexagonal green logic blocks, known as Booleans. The AND block requires all conditions to be met simultaneously. The OR block requires at least one condition to be met, offering an alternative path for success. And the NOT block simply inverts the truth value. By combining these Boolean operators and slotting them directly inside an orange if/then control block, you can easily engineer complex, dual-path branching logic for decision-making in your projects. It's super powerful.
Section 5. Variables and data storage. Giving your project a memory.
To build a truly rich, interactive world, your game needs a memory. And that brings us to the orange and red data blocks, starting with variables. Think of a variable as a custom-labeled box that you create to hold a piece of information, like a numerical score or maybe a text-based player name. During runtime, you can overwrite this box's contents, change it incrementally when a player scores a point, or even display it as a live monitor readout box directly on the stage for the player to see.
But what if you need to remember more than just one thing? Well, while a standard variable tracks one single, isolated piece of data at a time, a list is entirely different. A list is an array container. It dynamically expands, acting as an ordered system that can hold multiple data items simultaneously. If a variable is a single box, a list is a filing cabinet where you can insert, delete, or replace items at specific numerical positions. It is absolutely perfect for managing an entire inventory of items for a player.
Section 6. Creating custom blocks. Advanced builder skills.
Finally, for the ultimate builders out there, we reach the bright red My Blocks category. As your universe expands, your code can get pretty messy, right? Well, clicking Make a Block opens a configuration menu allowing you to build your own custom reusable functions. You get this massive red define block which acts as the header anchor in your workspace. You attach your incredibly long repeating code structures under this one anchor. Then, anytime you need that massive action to happen, you just drag out your single tiny custom red function block. It keeps your script area professional, pristine, and incredibly efficient.
We've systematically snapped together the pieces of motion, logic, and memory today. We've explored the layout, the color coding, and the massive, massive potential hidden within the Scratch 3.0 window. Armed with the full power of visual coding and a much deeper understanding of how these brilliant blocks connect, the only question left is, what interactive world will you build first?